This video is on propagation of error, and so I'm going to set up a problem here for you and then give the result values here. So there's the three values I have: 25.31 plus or minus 0.05, 24.02 plus or minus 0.06, and 23.64 plus or minus 0.07. So what I'm going to do is add and subtract these values. But first, I need to talk a little bit about what these mean. So 25.31 plus or minus 0.05 means that when we measure the value, we're going to obtain 95% of the time a value between 25.26 and 25.36. This is the range over which we would expect to measure the value every time we measured it. Same with this one. 24.06 would give us 23.96 to 24.08, and we again would expect to measure 95% of the time when we make a measurement, we're going to fall between these two numbers. That's what the 0.06, the 0.07, and the 0.05 mean. Okay, all numbers are like that, and you're going to deal with all numbers in lab reports, and in the lab, you always have an error on them. Always have an estimated range. So how we do this, let's take a result. I'll just call it R equal A plus B minus C, which gives us 25.31 plus 24.02 minus 23.64. And notice something I did here. I did not include the errors in this calculation. They're up here. I leave them up here. Okay? I don't put them in the calculation. We'll deal with them later. I do the calculation with my raw values, my actual values, the 25.31, the 24.02, and the 23.64. That gives me a value of 22.69. Now, what I want to know is, what is our plus and minus value on here? Okay, with sig figs, we would have reported this to the least precise, and so the value would have been just reported 22.69 with sig figs. And sig figs are a poor estimate of the error. Propagation of error will trump sig figs every single time. Okay, and you got to be aware of that in your lab reports. So how do I get the error? The error is really simple. The error in the result is equal to the square root of the sum of the squares of the errors of the individuals. So the error in A squared plus the error in B squared plus the error and C squared. Doesn't matter whether you add and subtract, you always add those squares. And so our value here is going to be the square root of 0.05 squared plus 0.06 squared plus 0.07 squared. And that gives us a value equal to 0.104. So my result up here, the 22.69, how I report this is R is equal to 22.7, 22.7 plus or minus 0.1. Now what I did to do that is I took this digit that controls the plus and minus, and it also controls how well how far I report it. It tells me I have to have these two digits be exactly the same precision. Okay, this is a hard concept for some people. You don't have sig figs in this number. Sig figs are thrown out the door for this. We'll talk about how to report that in lab reports, but you need to be able to do this. Okay, let's do multiplication and division. Okay, so here we go. I have down here, I have set up a set of three numbers, 5.13 plus or minus 0.04, which means a range of 4.09 to 5.17. That's where, when we make the measurement of this value, we expect to be between these two numbers 95% of the time. Same here, 6.12 plus or minus 0.05 gives us 6.07 to 6.17, and 4.21 plus or minus 0.03 gives us 4.18 to 4.24. Okay, so in this case, I'm going to take my result, R is equal to A times B times C, which is really easy. That's 5.13 times 6.12 times 4.21, and I get a value of 129.349. Now what I want to know is, what is the plus or minus value? Okay, I want to know that range, the error. The equation is the error in R divided by R is equal to the square root of the error in A divided by A squared, look familiar, plus the error in B divided by B squared, plus the error in C divided by C squared. So this is what you do for multiplication and division. Doesn't matter at all whether you divide or multiply. This is how you do it. Okay, and so our value is going to be, I'm going to rearrange the equation. The error in R is equal to R times the square root of the error in A divided by A squared, plus the error in B divided by B squared, plus the error in C divided by C squared. Okay, so now I just plug in my numbers. The error in R is equal to 129.349 times the square root of this monstrosity, 0.04 divided by 5.13 squared, plus 0.05 divided by 6.12 squared, plus 0.03 divided by 4.21 squared, and I get the error is 1.78. Okay, so how do I report my value? The error is going to be plus or minus 2 here. I round this, and I get 129 plus or minus 2. This time the sig figs matched. It doesn't always happen that way. When you multiply and divide, that error keeps growing, and you can lose sig figs. So when we do all calculations in the lab, we use these propagation of error rules. If you don't know how to do it, or if you don't understand what to do in some of the problems in the lab, you need to ask. All right.